Hi, I'm Carlos Dominguez, Senior Tools Engineer at Qualcomm Technologies. Today, I'm excited to introduce our Vulkan video series and give you a brief introduction of Vulkan in Qualcomm Snapdragon processors. Vulkan is a brand new 3D graphics API from the Khronos group. Similar to OpenGL and OpenGLES, Vulkan addresses the specific needs of the graphic developers like you who are involved with video games, engineering visualizations, flight simulation, VR, and other graphic-intensive applications. Vulkan is designed to run on currently available hardware such as PCs, gaming consoles, and mobile hardware. Qualcomm is a Khronos Group member with promoter status. With this affiliation, we participate in the design and specification of the Vulkan API just as we did with the OpenGLES standard. At Qualcomm, we're deeply engaged with Vulkan and we're working hard on our graphics driver development for our industry-leading Qualcomm Adreno GPU to ensure our current and future devices are fully supporting Vulkan. First, I'd like to share some of the key design goals and guiding principles of Vulkan. The Vulkan API is clean and modern. It is no longer a monolithic state machine or massive collection of APIs as with OpenGL. Vulkan's minimal driver, the ability to pre-compute state, and multi-threaded nature, among other features, allows you to minimize the driver impact and CPU overhead, making your app's performance more predictable. Vulkan was designed with cross-platform in mind. The API works on desktop, mobile, and embedded hardware with minimal variation. Vulkan introduced a new layering system, allowing developers to add and remove layers as needed. For example, validation and profiling layers can be added during development, which can be removed in production environments. Developers now have full control over memory access and synchronization of rendering events. You can now take full advantage of all CPU cores to generate and submit tasks to the GPU. Now that you have a bit more background on what Vulkan is, it's equally important to know what Vulkan is not. As a developer, you should be aware that Vulkan is not just a new version of OpenGL with an updated spec. It's also not backwards compatible to previous graphics and compute APIs. Vulkan has been redesigned from the ground up and requires applications to be significantly redesigned. One example of this is that Vulkan is not a state machine like OpenGL is. You'll find it more object model with just a few key objects and relationships to be aware of. Unlike OpenGL's black box approach, Vulkan requires developers to be much more explicit. While Vulkan has a sharp learning curve, it also gives you significant advantages. Vulkan is a highly functional API that gives you the ability to maximize your app's performance on a wide range of hardware. That means there's no longer the need to have differing desktop, console, and mobile versions for your graphics and compute engines. It's also architecturally neutral. Mobile devices with tiling architectures such as Qualcomm Adreno GPUs are first-class citizens to Vulkan, which allows us to perform exceedingly well. It's a clean slate and consistent API not bogged down with the extensions or a legacy of hacks. Also, Vulkan's multi-threaded capabilities allow developers to easily use all CPUs to do productive graphics work in your applications. And best of all, performance of your app will greatly improve, now that you're in full control of the graphics rendering. Performance will be a lot more predictable with more explicit upfront setup and no deferred validation or shader compilation. Next, I'd like to go over several of the most significant Vulkan features that will be covered in more detail in future tutorial videos. WSI takes care of the link between the device's native windowing system and your app. Its nature allows you to use the same code on all platforms by exposing what queues support presentation. Applications explicitly control which images and when to present them. Vulkan also comes packaged with a cross-vendor intermediate language with a GLSL frontend called SpearV. Currently available GLSL shaders require minimal modification to work with Vulkan. Vulkan introduced a new concept to optimize multiple passes over render targets of the same dimensions. This is particularly important on Qualcomm Adreno GPU's tiling architecture, as the buffers used while rendering can stay on the graphics memory, greatly improving performance by avoiding round trips to main memory. In order to make this all happen, Vulkan has also introduced a set of new objects such as command buffers and command queues that are used in order to encapsulate the work submitted to the GPU. Pipeline state objects hold much of the rendering state organized in several logical categories. The main two resource types are buffers and images. Memory allocation and access of these resources are the responsibility of the developer. Finally, descriptor layouts and sets were also introduced to describe the specific resources that shaders will access. Thank you for watching. Please visit Qualcomm Developer Network to learn more about graphics and tools on Qualcomm's mobile hardware.